Well, hello, algebra students. In this lesson, we are going to be talking about rates, ratios, and proportions. Oh my. In this lesson, we're going to be learning about things that we've already been doing in algebra. All right, we've already been talking about rates, ratios. Well, the word ratio should sound familiar because we've been dealing with rational numbers, and rational numbers are numbers that are expressible as ratios. Then we're going to talk about proportions, which is when we introduce an equal sign into ratios. Let's get started. The first thing we're going to do is define what a ratio is. A ratio is simply a comparison of two quantities using division. 6 over 5, 2 over 1. 2 over 1 is an interesting one because the number 2 is technically a ratio because it's 2 over 1. 3 over 4. We could say something like 25 miles per 1 hour. Okay, those are all examples of ratios comparing two quantities. Could just be a number, could be a number with a label. Technically, it could even be variables, right? Two quantities using division. That's what a ratio is. And then once again, just want to point out that when I talk about ratios, we're really talking about rational numbers. And remember, rational numbers not only includes numbers expressed as fractions, but also any more specific categories of numbers compared to rationals. Integers, whole numbers, and natural numbers are all examples of rational numbers that can be expressed as ratios. A rate is a special kind of ratio where we compare two quantities using different units. This is the example I said before where we have like miles per hour, 60 miles per hour. One quantity is in miles, one quantity is in hours, and I'm comparing the two. And what that allows me to do is compare how one quantity changes as the other changes. Time is going to go past. In fact, a whole hour might go past. How did my distance compare to the time that went past? I went 60 miles for every 1 hour, 60 miles per hour. That's a rate, okay? Anytime we have two quantities that have different units, we're dealing with a rate. A unit rate is a rate whose denominator is 1, and that's the kind of rate I just read off, 60 miles per hour. I could say 60 miles per 2 hours. That's only, if I change that one to a unit rate, that would only be 30 miles per 1 hour when I divide it. But anytime you have a rate, remember, has two different quantities being compared that have different units, and the denominator is 1 because I actually just do the division problem for the numbers. That's called a unit rate. We've been dealing with unit rates with unit conversion factors anytime we've been dealing with anything that was per hour, per minute, per second. Okay, so we have been dealing with a lot of these concepts so far this year, even though we didn't call them that. And then lastly, this is probably a new one for us. You've probably done this before, but just not in this class. A proportion is an equation that shows that two ratios are equal to one another. Now, we have one little hint on how to solve proportion problems. Anytime we have two ratios with an equal sign, this only works if you have two ratios on either side of an equal sign. Do not use this if we have an expression where two fractions are being multiplied together and there is no equal sign. This will not work. This only works if we're dealing with two fractions on either side of an equal sign. Cannot stress that enough. Okay, and then notice we have these qualifiers because the domain of our function can't include anything being divided by 0. So b can't equal 0, d can't equal 0. If I have a over b equals c over d and b and d are not equal to 0, I can solve this by cross multiplying. This is the cross products property. AD equals BC. And then AD and BC are called cross products. All right, we'll get to a problem we can use that for in just a bit. Let's start our lesson practice. First question is, which is the better buy? 8 boxes for $4.96 or 5 boxes for $3.25? This one's going to be a lot easier if I have a calculator to do it. So I might just open a tab and go to my Google calculator here. Now, what am I going to need to do here? You know, if I have 8 boxes, this is really hard for me to compare. This would be a lot easier to compare if I had a unit ratio with dollars per one box. Okay, so I put dollars on the top, boxes on the bottom, my first ratio would be 496 per 8 boxes. That is not a unit ratio yet. My second ratio would be $3.25 over 5 boxes. Okay, so now I need to take each of these top numbers and divide. So let's do 496 divided by 8. 4.96 over 8 is 62 cents. 62, let's see, so it's $0.62. So we know that's 62 cents or $0.62 per box, okay? And then, so that's what that one's equal to. That's the unit rate. Let's see what the unit rate of our second one is here. So it's 325 divided by 5, 3.25 over 5, gives me 65 cents per box, $0.65 per box. Which one's the better deal? Well, as long as whatever I'm buying, I could use 8 boxes of it, this is less per box. So the unit rate shows me that this top one is a better buy. All right, letter B. Chemists raise the temperature of a liquid 45 degrees Fahrenheit in 1 minute. What is the amount in degrees Fahrenheit per second? All right, so this is 45 degrees Fahrenheit, and then this is per 1 minute. So I'm just going to put that denominator here, 1 minute. And then let's go ahead and give this a fraction bar. There we go. Move this over a little. All right. And then the question is, what is that per second? So I'm going to need to multiply this times some kind of conversion factor. Let's see. I know that 1 minute equals 60 seconds. So if I'm going to multiply this by conversion factor, I'm going to choose things that are equal for the top and bottom of my conversion factor. Do I want to do 1 minute over 60 seconds or 60 seconds over 1 minute? Well, seeing as I have minutes on the bottom here, to cancel that out, I need minutes on the top for my conversion factor. 1 minute, and then on the bottom, we're going to put 60 seconds. All right. Now, this will give me degrees Fahrenheit per second. I can do this math in my head. This isn't too bad. It's going to be, so minutes is going to cancel, by the way. That's good. 45 divided by 60, that's 3/4 or 0.75. And this is going to be degrees Fahrenheit per second. 0.75 degrees Fahrenheit per second. All right, let's go on to letter C. In letter C, we have Jamie typed 20 pages of a document in 2 hours. How many pages did she type in 1 minute? Why, this is another unit conversion factor problem, different from ones that we've done before. So 20 pages per 2 hours, okay? And then I want to know what I have to multiply this by to get this into pages per minute. Well, let's see. I know that there's 60 minutes in an hour, and then I know that there's 60 seconds in a minute. I wonder if I could just do those two in a row. So let's do 20 pages per 2 hours. Now, first of all, let's do this. 20 divided by 2, I can simplify this fraction right away. That's 10 pages for every 1 hour. So she was typing 10 pages per hour. Now, let's finish this up. 10 pages per hour times 1 hour, and here, I'm just going to, 1 hour per 60 minutes. Okay, so that's a good conversion factor to have there. And then I'm going to multiply again times 1 minute per 60 seconds. Okay, and that should get me, let's see, hours are going to cancel because I have one on the bottom, one on the top. Minutes are going to cancel. So I'm going to be left with pages per second. How many pages per second did she do? Well, this is going to be 10 divided by 60. So that's 1/6 of a page per second. And then that number, 1/6, also divided by 60, that's going to be a really, really small number. how many pages? Oh, wait a second. I did pages per second. I only had to do pages per minute. Well, that's how you would do pages per second, but we can get rid of this last conversion factor because we don't need it. She did 1/6 of a page per minute. 1/6 pages per minute. All right. We'll do this, page per minute. All right, and that's how we do that one. I almost went one step too far. I thought it was asking for pages per second. Let's do letter D now. For letter D, we're going to cross multiply. Okay, so normally I'd write out the fraction first, and then I draw my little lines connecting the top and the bottom here, top and the bottom here. The only reason I know I can do this cross multiplication is because I have an equal sign between two ratios. That's a proportion. So this is going to be 21 times C equals 3 times 7. If I simplify that, I get 21C equals 21. Divide both sides by 21, I get C equals 1. C equals 1. So 1/7 is the same as 3/21. Makes sense to me. Let's look at letter E. Letter E is a little harder, but I'm just going to do cross multiplication. 10 times n plus 2 in parentheses, okay? Because I'm multiplying 10 times whatever this quantity is. I have to make sure I keep n plus 2 in parentheses. The whole thing is being multiplied by 10. Equals 5 times 16. Well, I'm just going to simplify that right away. Well, we'll just write it out. Okay, so this is going to become, let's see, if I distribute this 10n plus 20 equals, and then 5 times 16 is 80. Next, I'm going to subtract 20 from both sides. It's going to be 10n equals 60. And then divide both sides by 10, n equals 6. Let's just make sure that this makes sense. 5 over 8 equals 10 over 16. Yeah, that makes sense.